Hi, welcome back. In these videos, we're looking at solving inequalities. Just like in our solving equations section, when we are solving inequalities, we are making true statements. So we're looking for the value of a variable that will make a true statement. We're remembering that for inequalities, any numbers a and b, exactly one of these statements is true. So making true statements. When we worked with solving equations, we had properties of equality, and now we're going to have properties of inequality. If we look at the addition property of inequality, for any real numbers a, b, and c, if a is greater than b, then we can add the same value to each side of the inequality, and the inequality symbol stays the same. So that's if 4 is greater than -1 and I add 7 to each side, 11 is still greater than 6. I don't change my inequality symbol, and I still have a true statement. If a is less than b and I add the same value to each side, my inequality symbol holds. So 3 is less than 10, I add 2 to each side, and I still have a true statement. So that's my addition property of inequality. My subtraction property of inequality is very similar for any real numbers a, b, and c. If I have an original statement, a is greater than b, and I subtract the same value from each side, my inequality symbol stays the same. So that is 4 is greater than -1. If I subtract 7 from each side, -3 is still greater than -8. So if I look at that on a number line, I had -1 and 4. And I subtracted 7 from each of these. Oh, that's going to get complicated. But if I subtract 7 from each of these, I now have, this becomes -8 and this becomes -3. The distance between them is still the same, and -1 became -8, 4 became -3. So -8 is still smaller than -3. Same thing is true if a is less than b, then I can subtract the same value from each side and my inequality symbol holds. So 3 is less than 10, subtract 2 from each side, and 1 is still less than 8. So my inequality direction stays the same. So these are basically allowing me to add and subtract values from both sides of an inequality without having any major difficulty. So if I want to solve inequalities and graph the solution, so I want to solve y minus 6 is less than 3. So that means I can start by adding 6 to each side of my inequality, and I get y is less than 9. So when I graph on a number line, I like my students to include 0 on the number line and the value. So 9 is my value that I'm interested in. I want 0 so that I can tell where 0 is on my number line to make sure I'm oriented correctly. Y is less than 9. Less than is going to be one of these symbols. So at 9, I'm going to graph an open circle. And when I'm graphing less than 9, I'm going to ask myself, does 0 work? So I'm going to generally check a value, just like we've been doing all along. I am going to check a value, and the value I'm going to check here is 0. So if I plug 0 into my original inequality, 0 minus 6 is less than 3. So I'm checking y equals 0. Is -6 less than 3? Yes. If I get something that's a true statement, I'm going to shade that side. So I'm going to shade over here, and that will be my solution. And if I'm looking at this, I'm going to subtract 4w from each side using my subtraction property of inequality. So that will give me w plus 3 is greater than 9. Now I'll subtract 3, and I get w is greater than 6. So again, I include 0 and 6. I'm looking at a greater than symbol, which will be an open circle. So now if I check w equals 0, 5 times 0 is 0, plus 3 is greater than 4 times 0, which is 0 plus 9. So I'm plugging into my original inequality. Is 3 greater than 9? It is not, so I want to shade the other side. This process of checking which side I should shade is going to be really important when we move forward later on in the year.